Hello children, today's topic is remainder theorem. Before we study this theorem in detail or we see the mathematical presentation of statement of this theorem, let us take one simple example. If I say divide 15 by 2, divide 15 by 2. So when you divide this 15 by 2, it's 7 times 14 and 1. You will find that 1 is remainder. Okay? When you divide 15 by 2, so you will get this 1 as a remainder. So this 15 is called dividend. This 2 is called divisor. This 7 is called quotient, and the remaining, this one is called remainder. Okay, so when you divide this 15, so this 15 can be written as 2 multiplied by 7, because 2 sevens are, so 15 is divided by 2, so this 15 can be written as 2 sevens are 14 plus 1 15. Okay, take one more example. Divide 5 by 2. Divide 5 by 2. Then this 5 can be written as 2 multiplied by how many times? 2 3s are 6 and 2 2s are, so twice only. So 2 2s are 4 plus 1 is remainder. Okay, take one more example. If I say divide 7 by 3, divide 7 by 3. So this 7 can be written as 3 multiplied by some number plus remainder. Okay, divide 7 by 3. So 7 can be written as 3 multiplied by some number plus remainder. Okay, so 3 2s are 6 plus 1 as a remainder. Take one more example. 9 divided by 2. Okay, if I say divide 9 by 2, so this 9 can be written as 2 multiply by. Okay, 2 4s are 8 plus 1. Similarly, divide this 23 by 3. Then this 23 can be written as, 3 multiplied by some number. Okay, so 3 sevens are 21 plus here 2 is remainder. Okay, if question is divide 27 by 3, in that case this 27 can be written as 3 9s are 27. In this case remainder is 0. Understood? So this is called dividend. So in each case, so in general form, we can write this dividend is equals to divisor multiplied by quotient plus remainder. Okay, whenever we divide any number, so this number is called dividend, which is equals to divisor multiplied by quotient plus remainder. Okay, first thing. Now same thing is applicable for polynomials. Suppose if we have two polynomials, px and gx. Okay, px and these are just name. Okay, we can have x square plus 2 and here x minus 1. So in general we are writing two polynomials px and gx. And be careful, in first chapter we have discussed that if you write a upon b, then this denominator should not be equals to 0. We simply write 2 by 3 because we are sure that this 3 is not 0. But if we write in terms of variable, then we need to mention that denominator is not 0. Okay. And one more thing, in each case, this dividend is greater than this divisor. Okay, this dividend is greater than divisor. 5 is greater than 2, 7 is greater than 3, 9 is greater than 2, 23 is greater than 3, 27 is greater than 3. So in general, this dividend is should be greater than divisor. Or when we talk about the polynomials, we will say let px and qx are be two polynomials such that degree of this px is greater or equal to degree of gx. Or in simple word, we can say that in this example, this 9 is greater than 2. Okay, so this is like 9 and this polynomial is like 2. Okay, we'll just compare just to understand this theorem. Let us take two polynomials px and gx, and they are like these two numbers 9 and 2. And since this 9 is greater than 2, similarly degree of polynomials, degree of px should be greater or equals to gx. If they are equal, why equal also? Because we can also write 2 divided by 2. If 2 divided by 2, then in that case this 2 can be written as 2 multiplied by 1, and here remainder is 0. Okay, so that is why we are writing greater and equal. So here px and gx are two polynomials, and degree of px is greater or equals to gx, and also we will write gx in the denominator, so we need to mention that gx is not 0. Okay, then now we will write this in this form. Okay, we will write this dividend is equals to divisor multiplied by quotient plus remainder, but in for the polynomial. So we will write this dividend, here dividend is px is equals to divisor is qx, and here quotient. So in quotient we will get another polynomial, so let it be qx, plus we will get remainder which is again a polynomial, so let it be rx. So here this we have written for numbers, dividend is equals to divisor multiplied by quotient plus remainder, and for polynomials the same thing can be written like this: p of x is equals to g of x multiplied by qx plus rx. Okay, and in all these numbers you will find that this remainder is either 0 or less than divisor. Okay, the remainder is either 0 or less than divisor. Here divisor is 2 and remainder is 1. Divisor is 3, remainder means in each case divisor, here divisor is 3, remainder is 2. So in each case remainder is always less than the divisor. Okay, either 0 or less than divisor. So similarly this is the remainder, so we will write the degree of remainder is either 0 or less than degree of divisor, means gx. Okay, it takes time. Okay, this is very simple, but this takes times. Okay, so you watch it again and again, you will definitely understand. Okay, so now when we divide a polynomial by another polynomial, so first we will learn how to divide. Okay, how to divide a polynomial. Let's take x plus 3x square minus 1 by another polynomial 1 plus x. Okay, so first we will learn how to divide both are polynomial. So first we will learn how to divide a polynomial by another polynomial. Okay, so whenever you find this type of question divide, so first thing we have to do is we have to write the polynomials in the standard form. We have to write it in the standard form. Now what is the standard form? Standard form means we have to write the polynomial in the descending order of their power. Means first we'll write the term with the highest power. Okay, so here we have to divide this one, so let it be px, and as well as we'll write this polynomial in the standard form. Means first we will write the term with the highest power. So here the highest power term is 3x square, so first we will write 3x square, and then the decreasing order of their power. So first power is 2, then next power is 1, and next power is, okay. So this is our dividend. Now we have to divide this by this polynomial. So here also we have to write in the standard form. So first variable and then last constant. Okay, so this is the first thing we have to do. If in sometimes you will find that the question is already in the standard form, then no need to convert. Suppose if the polynomial is not written in the standard form, then first you write in the standard form and then divide. Okay, now what we have to do? Now we have to divide this px by this gx. So as usual, we will write this px, which is a dividend. We will write it here. This is same as divide 9 by 2. So we'll write 9 here and 2 here. Okay. 3x square plus x minus 1. This we have to divide by x plus 1. Now divide 9 by 2 is very simple because we know the table, but how to divide this polynomial? So we have particular steps, process to follow. Okay, process of division. So we need to follow these steps. So the first step is, in the first step what we will do, the first term of this polynomial and the first term of this polynomial we will divide. Okay, instead of dividing the whole polynomial by this whole polynomial, we'll divide the first term by the first term. Means we will divide this 3x square by x. What is the answer? This 1x and 1x will cancel out. So we'll get 3x. Okay. Now, whatever the answer comes, whatever the answer, here we are getting 3x. So we will write 3x here. Okay. After writing 3x here, we'll multiply 3x with these two numbers. First with x and then with plus 1. So 3x multiplied by x, 3x square. 3x multiplied by plus 1. So plus 3x. So if whenever you do this, you will find that every time you will get this term same. Okay, that is what we are doing here. We just want to cancel out these two. So we will divide this one by this one, and whatever the answer comes, we will write here and then we will multiply. After multiplication, what we will do? We will subtract. We will subtract this one from this. So whenever we subtract, their signs will change. So right now this 3x square, this one, okay, which is written here, their sign will not change. Okay, only their sign will change. So this 3x square is positive, so this will become negative. So we'll put minus sign here, and this 3x is positive, so now this 3x will become negative. Now this 3x square is negative and this 3x is also negative. Okay, now simplify. So 3x square minus 3x square, 0. You can easily cancel. And then x minus 3x. What we have? X minus 3x means 1x minus 3x. So 1x minus 3x means minus 2x. Okay, and this remaining term we will write as it is. So here we have completed first step. Let us see once again. In the first step, what we will do? First term divide by first term. What is the answer? 3x. So we will write it here, and then this 3x multiplied by x, 3x square. 3x multiplied by this one plus 3x. Now what we will do? We will change their signs, okay, because whenever we subtract, their signs will change. So this is positive, this will become negative, and this is also positive, so this will also become negative. And every time this first term will always cancel out. Okay, so here this term will cancel out. Now we have 1x minus 3x. We will consider this sign now, okay, not this one. So 1x or simply x. So x minus 3x is minus 2x, and this minus 1 as it is. This sign will not change, only their sign will change. Okay. First step is over. Now again we'll repeat the same procedure, okay, because still we have x raised to the power, their degree is same, so we can divide, right? So again we will repeat the same procedure. First term divide by first term. So here first term is minus 2x, we cannot ignore the sign. Here first term is minus 2x, so minus 2x divided by x. This first term minus 2x divided by x. So this x and x will cancel out, so we'll get minus 2 only. Okay, what is the answer? Minus 2. So we'll write this minus 2 as it is here along with the sign. Okay, now this is minus 2, so this minus 2 multiply by x and minus 2 multiply by this one. Okay, along with the sign we will multiply. So when you multiply minus 2 and x, you will get minus 2x. Every time you will get same digit here. Okay, same digit. So minus 2 multiplied by x is minus 2x. This plus minus minus. 2 multiplied by 1 is 2. After doing this, what we will do? We will change their signs. This is negative, so this will become positive now because we are subtracting, and whenever we subtract, their signs will change. So this is negative, so this will become positive, and this is negative, this will also become positive. Now simplify. Minus 2x, now it's plus 2x, so minus 2x plus 2x 0. Okay, minus 1 plus 2, minus 1 plus 2 means 2 minus 1 1. So when we divide this 3x square plus x minus 1 by x plus 1, this 1 will get as a remainder. Okay, this is called dividend, divisor, quotient and remainder. So we can write it as, we know that this dividend is equals to divisor multiply by quotient plus remainder. Here dividend is 3x square plus x minus 1. Divisor is this x plus 1. Quotient is 3x minus 2. It's one term, that is why we are writing in bracket. It's complete one term, that is why we are writing in bracket. And plus remainder, remainder is 1. Okay. So again, if you simplify this right hand side, you will definitely get this one. Okay, so this is how we can divide a polynomial by another polynomial. So this method of dividing a polynomial by another polynomial is called long division method. Okay, this method is called long division method. But why there is a need to study this remainder theorem? Okay, what is the use of remainder theorem and what is this remainder theorem? So now we will discuss it.